Hello, and welcome to this talk on pragmatic DevSecOps security controls. Um, I hope everyone can hear me, and if you can't, please spam the question chat so I can fix it. But I think we should be good. Um, so let's just dive right into this. The main topic of this is the new era of DevOps, and what that means, I will explain to you shortly. My name is Sergey. I work at CyberCrypt as a cloud security developer. Uh, at CyberCrypt, we deliver products and various security services for our clients. And what I do is that I mainly work in the you can say the cloud team with the DevSecOps and helping clients to get started and get into DevSecOps in particular. So let's go ahead and jump right into it. New era of DevOps. What that is, I'll tell you shortly. This talk is gonna be in two parts. The first part, I'm gonna talk about what we think the new era of DevOps is here at CyberCrypt, and how some of these security controls in the cloud they might look like. And in the second phase of the talk, I will show you hands-on how to apply these security controls and how we do it here in our organization, both internally and also externally. So the agenda is that I would like to motivate this talk first. I would like to tell you why I think the subject is important, and it has a lot to do with the default security that is in many of these DevOps technologies. Uh, we will look a bit about how you can improve your DevSecOps posture in your organization or in your company, and I will take inspiration of some of the tools and frameworks we use in our company internally. And at last, we will show you a hands-on demonstration on how to apply some of these security controls and techniques. So let's have a look at some of these default security controls that exist in many of these cloud-native technologies, such as Docker and Kubernetes, for instance. Uh, and actually the lack of security in there. That's my main point, I think, is that many of these technologies, they are easy to use as default, and they're designed in a way such that it's easy to get up and running. But if you look at some of the security features that is in Docker, for instance, when you start up a Docker container, it starts up with a lot of default Linux capabilities. One of these capabilities is this something called a catnet rock capability, which allows you to sniff network traffic in your containers. Now, 99% of all of your applications probably don't need this capability, but it's just there by default because in case your app needs this, then it is there. The same goes for Kubernetes has some very tolerant security defaults. For instance, when you start up a container in Kubernetes, by default, it is started as root unless otherwise specified in the Kubernetes spec or in your image. We have also encountered some cloud providers that have a very broad permission settings where you basically, if you just have an account at the cloud provider and you are attached to a project, you have super admin rights and can do anything you want. So this is just to illustrate that many of these new technologies or kind of new technologies, they have very lenient security defaults. And this actually directly contradicts this. I don't know if you've heard about it. There's this security principle of fail-safe defaults, which basically I can read it out for you. It says that unless a subject is given explicit access to an object, it should be denied access to that object. What this basically means is that in security, we want to blacklist things by default and then whitelist the objects that we know are supposed to be there. So this kind of so these defaults in these cloud native technologies directly contradicts this IC security principle, if you might say. And it's not that this is bad per se. I believe it is designed that way, such that these technologies are easy to use. Personally, as a developer, I love just running some code that I found on GitHub, and everything works just with a one-liner. I mean, that feels awesome. That feels like I'm getting somewhere. Um, I don't want to apply thousands of configurations and security protocols and security controls for my application to be running. Uh, so this obviously has to do with this usability and security trade-off that you probably have heard of. There is always this trade-off, because if you increase security, then it is harder for you to use the application. So let me quickly show you a graph that I tried to draw. It's not that advanced, but this is what I believe that this usability and security trade-off might look like. So it basically illustrates that the more security you introduce, the less usability you get. And what I believe, and what we at Cybercreek believe, is that there is this another dimension to it, another element to this trade-off, which is called maturity. So it's like a third dimension, if you might say. And what this basically means is that the more mature your technology is, and the more mature and adapt your users are to the system, the less you can say that this trade-off gets softer. So if a technology is very mature and the developers using it are experts in the technology, you can introduce more security and only pay a little bit of usability, if that makes sense. And what we believe is that a lot of these cloud native technologies, such as Docker and Kubernetes and other technologies, they have been going through a maturity phase. And also the users, the developers behind these technologies, and the developers who are using these technologies have also been going through a maturity phase, where they have been learning how it works, and also becoming an expert on these technologies. Uh, what this basically means is that we believe that the state of Kubernetes, Docker, and some of these CI/CD pipeline tools, and etc., it's different now than it was before. And I think what I'm trying to communicate is that what is the new era of DevOps? Well, we believe that you cannot spell DevOps without automatically saying DevSecOps. So we can demand more security today in these technologies than we could before, because the trade-off is softer, because the users are more mature and they know how to use these technologies. So we believe it's time to demand more security. We believe it's time to increase the security controls in our deployments, and to be more serious about how we do DevOps. You might also have experienced that the term DevSecOps, it is mentioned more and more, and it's like emerging, almost overtaking DevOps. And for us personally, when we speak about DevOps, we automatically mean DevSecOps. Security should be an integral part of that story. So, having established that we need security, and in fact, we can demand more security today than we could earlier, I will quickly cover how we handle DevSecOps internally in our organization, and how we kind of the mindset that we use when we assess external organizations as well. Um, so there is this framework that you can use, but uh, it's very diluted because we are under some time constraints. So basically, I can put it down in 3 points. The first point being that it's important to perform an honest assessment of your security controls, of your cloud security controls. And what I mean by honest, I will tell you shortly. The second one being when you have performed this security assessment, when you know what the critical points are, you need to identify those low-hanging fruits, because we also recognize that organizations are under deadlines and time constraints and resource constraints. So we want to apply that 80-20 rule or principle, where you get a lot of value for doing 20% of the work. And then you take action upon that assessment in the third step, and you elevate those deficient security controls. And you can view this as an iterative framework. So what we would do is we would go through these steps, and we will rinse and repeat until the required level of security posture has been reached. And this can be quite different depending on what kind of organization you are. So what do I mean by performing an honest assessment? By that, I mean that's what I believe personally, is that we as people, but also as organizations, are very biased, are very self-biased when assessing how we are doing and how we are performing. So a security self-assessment could look something like this, where you take a look at your security controls, you evaluate them, and you think that you are somewhere on this green line. But what happens usually when you bring in an external person, uh, either a consultant, but it can also be just a new employee in your organization, is that they'll often see something else, something different that you can see yourself. So maybe there is a container hardening policy that is dangling and that is very deficient and that needs to be brushed up a lot. So this will be something that an external person can see much more easily than you as an insider. Um, so so this results in this mismatch between your what you think is your security posture on your security controls and what is your actual security posture. And this is the mismatch that we want to eliminate. So that's why it's important to be honest against yourself, and by doing this with including outsiders, you can help yourself being honest in your assessment. The second thing you want to do is, of course, to identify these low-hanging fruits. You want to act quickly. So you can, but you probably won't like to fix everything at the same time, because there are these resource constraints and there are deadlines and there are these things where you simply cannot use all of your resources on security. So you identify the low-hanging fruits, right? You identify the ones that really need taken care of right now. And then what you do is you, of course, make a plan. So I'm doing this very broad now, but you make a plan and you act upon that plan and you elevate that deficient security control. And you do that to a point where you align your actual security posture with the one that you perceived before. So we want these lines to align, right? So we have been talking a lot about security controls, and what are they? Here is a list that I've tried to compile, and it's by no means an exhaustive list, but this is some of the security controls we use and we apply: container hardening, Kubernetes security policies, and etc. You're probably seen and can recognize many of these. These are the ones that we usually work with. Um, and now we're getting soon to the fun part, is where we actually want to demonstrate some of these security controls. And what we will be demonstrating is some container hardening techniques and some Kubernetes security policies and what impact they have on your security posture. So in the following videos, we will look at security from the perspective of an attacker. So we will actually be trying to penetrate a demo application that we made. And from the perspective of an attacker, we will see how the attack surface decreases, the more of these security constraints we apply. So for the first one, we will do we'll show something about container hardening. So to demonstrate some of these container hardening techniques, I've built this vulnerable application. This is just a simple web service where you can choose an oracle, and when you have chosen that, you can get it to read you a fortune cookie. So this app has a built-in vulnerability where the user input is not properly sanitized, and this enables the attacker to spawn a reverse shell and do other kinds of attacks. So let's try to execute this. If we go to the Networks tab and press the button, we can see the request. So in this request, we can actually see that the parameters which are executed on the server are constructed on the client side. So let's try to go ahead and change these parameters that the app is sending. So the command we will change from the cowsay binary to, let's say, bin.sh. And we'll add the command flag. And we can try to execute something else, like listing the root directory. And this works because the input is not properly sanitized. So let's try to see how we can use this to spawn a reverse shell. Over here, we will exec into an attacker container to simulate the attacker. So what an attacker would usually do is to listen for connections through a tool like Netcat, for instance. So we will do that here and listen on port 8081. And now we are just waiting for the victim to contact us with the reverse shell. So let's find the payload that we can execute. There is plenty of resources for that. I usually use this reverse shell cheat sheet, which is on GitHub. And it provides you with a lot of payloads you can use depending on what programs and libraries are installed on your target operating system. So we'll use Python because those are usually simple. And as you can see, there are plenty of payloads to choose from. We'll go ahead and grab one. And the only thing we have to change here is the attacker IP address. And also the port. And we will encode it because we're going to send this through the browser. And now let's go ahead and try to execute this as our payload. So we see that the browser hangs, and this is usually a good sign because then the server is probably doing something that it shouldn't do. And we can see over at the attacker side, we can in fact list the directory on the target machine. We can go to the root directory and we can read the passwords file. We can also go to the application directory where the site is hosted, and we can, let's say, override the HTML of the website. Now if we reload our website, then we can see that we have successfully overridden the contents of the site. So this is something that is known as a defacement attack, and a real hacker or an attacker would usually put something way worse on your website than this. So let's try to apply the first security control. So you can see here on the top we have a Docker file for the app, and it's not doing anything unusual, just copying some folders and building the application. So for the first layer of security, we will create a user for the service. So the only difference here is that we actually create a user and we specify that user as the runtime user for the container. So over on this tab, I have deployed the application with the new Docker file. It can still read the fortunes as before, but let's
try to do a reverse shell in this application. And we will repeat the procedure from before. Now let's try to execute the payload. We see the browser hangs once again, which is good. And we can see that we have a shell. But now if we want to read, let's say, the passwords file, which is hosted on the root, permission is denied. This is really good because then all the files not owned by the runtime user cannot be accessed. But we still have this thing where we can deface the website. That is because all the folders and files of the web application is owned by the web app user. So let's try to do that. And let's visit the site again. We can see it is still possible to override the contents of the website, but our access is now more restricted because we cannot do anything we want in the container. So let's try to apply yet another security control. I will bring up the last Dogger file, and this Dogger file applies another runtime image. You've probably seen files like this before, where you have a build phase with, let's say, the Golang container, which has all the necessary build dependencies, and then you have a runtime container to which you copy your build binaries and necessary files only for the runtime. This greatly decreases the attack surface because the container is simply slimmer. There are not that many files in the container that the attacker can use and exploit. So let's see this in action. We'll repeat the reverse shell procedure once again. Only now we have deployed the app yet again with the last Dogger file. See, only this time we get an error when trying to execute this payload. More specifically, we cannot execute bin.sh because this binary simply does not exist in the container. This is because we have used another runtime image which is slim and does not contain this binary. In fact, it does not contain any binaries at all except the web application that we are running. So as you can see, by applying these security controls, we can decrease the attack surface and limit the capabilities of the adversary. So you can see that the attacker can do less and less the more security controls you apply, and one of them is not necessarily enough to stop the attacker. This greatly depends on what kind of application and what kind of host you're running in your container.
So just to recap, let me bring up the slides again. Let me see. Sorry about that. Just to recap what we actually did there is that we applied 2 security controls, and they're by no means exhaustive, but they kind of give you an idea of, from the attacker's perspective, of how the attacker can do less and less the more we stack security, basically. What we did was we applied the runtime user to be non-root, and this already limited access to some of the application resources. What we did afterwards was to apply a runtime container, which was slim and almost had non-binaries installed on the host. And by doing that, we decreased the attack surface greatly because the attacker can only use what's there on the host. But by using a minimal container, we give them no options at all. So let's try to see a similar presentation of the security controls, but this time in a Kubernetes context.
So now I will try to show how we can use Kubernetes level security policies to mitigate some of these vulnerabilities that your application might have. I have started the application once again, but this time it's running in a Kubernetes setup. So you can see over here that if we get the pods, we have our application and we have an attacker pod to simulate the attacker. I'm currently listening on the attacker pod for remote connections. Let's try to do the reverse shell once again. I have the payload prepared here. the browser hangs, and we can do the stuff that we could before. We can read the passwords file, and we can also override the website HTML. So let's try to apply some of these security controls. You can see the Docker file, or sorry, not the Docker file, you can see the Kubernetes file on the right hand side where the container is defined. You can see that I have commented out this security context section. So by commenting this back in, it enables the read-only root file system. This is a nice security feature in Kubernetes. It allows you to start your containers in read-only mode. So the root file system is mounted read-only. So let's apply this and see what happens. So we'll give our container some time to reconfigure. You can see the attacker has already stopped listening because the connection is broken. So now that the app is back up again, we can try to execute the same payload as before. So we see that this works once again. If we try to read the passwords file now, we can still read it, but now we cannot modify it. So because we mounted this as read-only file system, we cannot modify anything in the root directory. This also goes for the website and its HTML. So a defacing attack like that won't work anymore in this context. So luckily for the attacker, there is still some security mechanisms broken in this setup that allows us to escalate our privileges and do more stuff that we can do now. One of them being that the RBAC, which is applied, grants us excessive privileges. So by looking at the Kubernetes spec file, we see that the RBAC is defined right here. We create a service account, and our pod uses the service account to read or list pods. As you can see here, it queries the Kube API to list some pods. But the privileges granted to the service account are excessive. As you can see here, this service account can do anything it wants. So we can do this. We can call the Kube API and modify the resource which controls our current container. By doing that, we can try to remove the security context. So let's try to do that now. Now, since the pod is using a service account to contact the Kube API, we know that the token is already mounted in the container. So we can use that token to contact the Kube API and try updating this deployment specification file. So our objective, just to recap, is to remove this security context. So let's try to apply a patch. A patch is just a small piece of the deployment specification which you can use to replace some of the file. In this case, what we're doing is, if you look at this line, we're replacing the security context read-only root file system with the value of false. So I have constructed this command that basically reads the service account token and curls the Kube API. And the data for the curl command is this patch that we're going to apply, which removes the security context. So let's try applying this. On the left-hand side, we're already SSH'd into the victim container, and we will try to contact the Kube API from within this container. So we can see that the command is successful and the patch has been applied. So let's now inspect the new pod that has been spawned. So we can see this pod spec on the right hand side. And searching for the security context, we can see that the read-only root file system has been disabled. So what happens if we SSH back into the victim container? Having access to the container again, we can try to read the passwords file, which we still can do, but now we can also modify the passwords file. This is because we've overwritten the previous configuration, so now the file system is not read-only mode anymore. So this is a good example of a broken RBAC and what damage it can do in your environment. So let's now apply some security controls for this. So what we want to do is we want to limit the privileges of the service account. A way of doing that is just restricting what type of resources the service account can access. So in our case, it's going to be pods. And what type of actions the service account can access. And in this case, it only needs actions such as get and list and watch, since it only needs to read the pods. Let's try to apply this. We see that the shell is broken once again, so we will need to SSH back into the container. So we have gained shell access again. Now let's try to override the file. It doesn't work as before, but let's now try to modify the Kubernetes spec with a patch, as we did before. So now we get an error code 403, which you know is access denied. So we cannot modify this resource anymore because we have restricted the access of the service account. As you can see, it can only get, list, and watch the pod's resource. So even though the service account is restricted and the root system is in read-only mode, we can still read the passwords file, which is a big issue, obviously. Reading these credentials can help us elevate access to the system even more. So let's shut this down completely by applying the last security control. So the last thing we want to do is to apply this network policy. What it will do is that it will select our pod with the label of app fortune seller, and it will restrict network access to the pod. So all ingress and egress traffic will be restricted to port 8080. This means that we will no longer be able to spawn a reverse shell. So let's try to apply the network policy. I'll simply comment this back in. And apply the YAML. So now that the network policy is applied, we can try to do something through our shell. As you can see on the left-hand side, we can no longer issue commands. This is because this traffic, which is established through Netcat, is now blocked. As you know, we established this connection through port 8081. So establishing a connection through any other port than port 8080 will not work anymore. And we also cannot establish connection on port 8080 for our reverse shell, since that port is already in use by the web service of the application. So as you can see, one security control is not often enough to secure your deployment. You need to choose a set of security controls which fit to your application and to your current threat model.
So I hope that at least some of you could follow along, although it gets a bit technical when you try to actually demonstrate these security controls. I think the main point to get from this is that exactly what I mentioned in the video as well, is that one control is often not enough, and you need to apply this defense in depth methodology and mindset of we need to apply enough such that our container and our app is completely secure. Another thing you should note is even though the app was vulnerable, we didn't modify the application code at any time. So the application code was still the same. It was still vulnerable and there was still an exploit in there. we only changed the runtime of the application. And by changing the runtime, we can in fact secure even vulnerable apps. All right, so let's just recap what we did quickly. We applied 3 security controls. We mounted the file system as read-only, and that prevented us from accessing some of the files. We fixed the broken RBAC, which is also an issue you see in a lot of deployments, which gives you the access to escalate your privileges. So you could see that we could actually remove the first security control because we had excessive RBAC access. And the last thing we did was we shut the network down completely by applying this network policy. This disabled the reverse shell that we tried to make into the container. So we have been looking at container hardening and Kubernetes security policies, and we have only looked at a small subset of all the policies that are available. I think my main message here is that you need to find the right combination of security controls that you need to use for your deployment. You probably don't want to apply all of this at once because speaking as a developer, I would not like to work with that myself because then it will be a pain and a hassle to develop and to modify the resources if you always have to think about 1,000 security controls. So you want to find that sweet spot between usability and security where the developer experience is still nice, but also where your replication is sufficiently secured. I think that was it for my part here. You are welcome to ask any questions. I'll be hanging around for a few minutes. Um, yeah, so we'll see if there's any questions, and if not, I hope you enjoyed the talk, and maybe I'll see you around. So there's a question on if I have any other resources to recommend for users just getting started in dev and ops and sec. Well, to to be honest, and just speaking as a developer, I use the internet a lot, and it's not a shame to say that you use Google for everything you do. So I think platforms such as Udemy, such as Cybery, I think it's called, all of these online tutorial platforms, they have a lot of great resources. It's not like you need a special guide or a secret book. You just need to consume these resources, and you need to be interested. What I find useful is also working on a real project or a hobby project at home and actually try to apply these things. That's the best way to learn. All right. If there are not any more questions, then I'll just say thank you for joining the talk. It was nice having you around. I hope you got something out of it. I hope you got inspired. Just reach out to us if you have any questions. I'll see you around.